I'm going to explain the reference values in the unit circle. So we all know that a circle has 360 degrees. The first value in degrees of circle is 0. Here is 90. Here is 180. 270. And 360. But in radians, this is different. First, we have 0 again. Here we have pi over 2 pi, 3 pi over 2, and finally a full rotation is 2 pi. Now, in this unit circle, we have the specific value of each of the points that we are using as a reference. But what about all the numbers that are inside the circle that we don't know the exact value that they have? So we're going to use a method. This is a table. First we have sine. Sine is the value of y, cosine, that is the value of x. So first we're going to start with the reference number 0. We're going to put the root square of 0 above 2. And we're going to do the same with all the reference numbers, but we're going to be increasing 1 in the root square. So this is what it should look like. And then in the cosine side, we're going to do exactly the same, but we're going to change the root square numbers. So we're going to start with 4 above 2, 3 above 2, 2 above 2, root square of 1 above 2, and root square of 0 above 2. But in this case, we cannot have the root square of 0 because the root square of 0 is 0, and 0 above 2 is equal to 0. The root square of 4 is 2, above 2 equals 1. So we have the first reference numbers of 0. 0 is right here. Then we also have this in the last one. The root square of 4 is 2, above 2 equals 1, and again 0. But if we want to know the exact position of a number, we must know the quadrants. In the first quadrant, sine is going to be positive, the same as cosine. In the second one, sine positive, cosine negative. The third one, sine negative, cosine negative. In the fourth one, sine negative and cosine positive. So if we want to know where exactly the point, for example, 11 pi over 3 is located in the circle, we have to use the denominator as a reference number. So we're going to look for this number here in the table that we just did. So when we locate the denominator in the table, in this case pi over 3, we're going to use these points to locate this example in the circle. So in this case, the points are root square of 3 above 2 and the root square of 1 above 2. To locating which quadrant this example is going to be, we have to divide these two numbers, 11 above 3. The result is 3.66. So we know that a full rotation is 2 pi. So we're going to have one rotation. This means 2 plus 1.66. So we're not going to complete the second rotation. So where is going to be this point? We know that here is 0, 0.5, 1, 1.5. So this example is going to be approximately right here. So if we remember, this is sine and this is cosine. So we located that this point was right here in the fourth quadrant. So sine is going to be negative and cosine is going to be positive. So it is important to remember that all points are going to have the reference number that is the denominator, that we're going to look in the table, and in this table we're going to obtain the sign of cosine. All points must have sine and cosine. So I'm going to do another example. In this case, 4 pi over 3. So we look for the reference number in the table, and here we have that pi over 3. Sine is root square of 3 above 2, and the root square of 1 above 2. But in this case, the root square of 1 is 1, so this is equal to 1.5. Okay, so if we remember the procedure, we have to divide 4 above 3, and so this point is going to be located in the quadrant number 3. So if we remember this chart, in the quadrant number 3, both points, sine and cosine, are going to be negative. So remember that all points in the circle must have sine and cosine. Remember, the sine is equal to y and cosine is equal to x.
2 hours later.
As we have seen previously, I'm going to explain you the trigonometric functions. So we have sine, that's y, cosine, that's x, tangent, that's y over x, or sine over cosine, that's the same. Then we have cotangent, that's the opposite of the tangent, that's x over y, or cosine over sine. The other two are secant, that goes with cosine, that's 1 over x, or 1 over cosine, and cosecant, that's 1 over y, or 1 over sine. Now I'm going to teach you how to obtain the values of the trigonometric functions using reference values. So for example, if we have pi over 3, we want to obtain all these functions. For example, for sine, we know that sine is y. So we go to our chart and we have that sine, it's equal to root square of 3 over 2. Cosine, that's equal to x. That's gonna be root square of 1 over 2. That's equal to 1/2. Let's go to tangent. That's gonna be root square of 3 over 2 divided by 1/2. So now we need to solve this division. So we use the sandwich law. That's gonna be over 2. And we simplify this, and the result's gonna be the root square of 3. That's a tangent. So now we have to obtain the cotangent. We are going to have the cosine, that's 1/2, over the sine, that's root square of 3 over 2. So now we need to solve this division. That's gonna be 2 over 2, root square of 3. We cannot have radicals, so we need to solve this, and it's gonna be, we multiply with the same radical, so this is going to be eliminated, and it's gonna be 2 root square of 3 over 2 multiplied by 3. That's gonna be, but we can simplify this, so the result, it's gonna be, so the result of the cotangent is root square of 3 over 3. Well, the next step, secant. The secant is equal to 1 over x. So 1 over 1/2. So the secant is gonna be 2. And finally, cosecant. That's 1 over sine. So we make this, and it's 2 over root square of 3. We solve this. And that's the result. This is the cosecant. Well, we have all the 6 trigonometric functions, and this is the same process for all the angles smaller than 2 pi. But what if we have a negative angle? As you know that if the angle goes this side, it's positive. If the angle goes the other side, it's gonna be negative. So for example, let's pretend we have minus p over 4. It's the same. It's gonna be in the quadrant 4. Okay? So we go with the reference values. Those are root square of 2 over 2 and root square of 2 over 2. So sine is gonna be root square of 2 over 2. Cosine is gonna be root square of 2 over 2. Let's find out the tangent. The tangent is gonna be sine over cosine. So root square of 2 over 2 divided by root square of 2 over 2. Yes? So using the sandwich law, it's gonna be 2. Yes? And as you know, this is equal to 1. So tangent is gonna be 1. And cotangent is the same, because cotangent is root square of 2 over 2 divided by the sine, so it's gonna be 1. Well, so secant is gonna be 1 over the cosine, root square of 2 over 2. This is gonna be 2 over root square of 2. But we need to solve this, so it's gonna be root square of 2 over 2. That's equal to root square of 2. And finally, cosecant. The result's gonna be the same because our sine is the same as the cosine, so it's gonna be root square of 2. And that's all. So now we have to obtain the signs. For example, sine, it's gonna be negative because it's in the quadrant 4. So sine is negative. Cosine is positive. So tangent, it's gonna be negative because minus divided by positive number is gonna be minus. And it's the same in the cotangent. Secant, it's gonna be positive. And cosecant is gonna be negative.
6.5 hours later.
So now I'm going to explain how to obtain a value that is greater than 2 pi. Let's take 15 pi over 4. And the first thing we need to do is to locate where this is going to be in the unit circle. So for that we're going to divide 15 over 4, and it's going to be 3.75. And we're going to take only the rotation, which is going to be just 1 because 2 pi here. So plus 1, 75. So it's going to be 1 loop, and the 1.75, which is going to be here. So it's going to be in the 4th quadrant. So now we're going to take the denominator of our primary number, and we're going to take our reference value, which is going to be pi over 4. So sine, it's going to be the root square of 2 over 2. Cosine, it's going to be the root square of 2 over 2. So now we're gonna go with the rest of the trigonometric functions, which is tangent, which is y over x, so sin over cos, so the root square of 2 over 2 divided by the root square of 2 over 2. So we're gonna use the law of sandwich. We're gonna divide this, no, multiply this over this, so it's gonna be 2 root square of 2 over 2 root square of 2, and it's gonna be equal to 1. So our tangent is gonna be 1. Now the cotangent is gonna be the same, but cos over sine, so it's gonna be 1. And second, it's gonna be 1 over cosine, so root square of 2 over 2. We use the law of sandwich, and it's gonna be 2 over the root square of 2. But we can have radicals on the denominator, so we multiply it by the root square of 2 over the root square of 2, which gives us 2 root square of 2 over the root square of 2 by the root square of 2 is going to be the root square of 4. Therefore, it's going to be 2. So this is our second.
Simplify that.
We can simplify it by canceling these 2's. So our second is going to be root square of 2. Now we're going to go with the cosecant, which is 1 over sine, so the root square of 2 over 2. So it's going to be the same as the second. Root square of 2. Now we need to find the signs for this. So we are in the fourth quadrant, and their y or sine, it's going to be negative, and x or cosine is going to be positive. So we have sine negative, cosine positive, and the tangent we're going to have negative over positive, so it's going to be a negative number. Now the cotangent is going to be x over y, so plus positive over negative, which is going to be negative. The second is going to be 1 over positive, so it's going to be positive. The cosecant is going to be 1 over y, so 1 over negative, it's going to be a negative number.
Bye bye.